In this presentation, we're going to see how we can use open automation software to log data from Industry 4.0 data sources. This would include Allen Bradley controllers, Siemens S7 controllers, Modbus slave devices and masters, OpenCO servers and clients, MQTT brokers and clients, and any data source that you can feed in like .NET applications, Excel, and web interfaces into open automation software. We can log this data in an open format to databases like SQL Server, Oracle, Access, MySQL, Postgres, Cassandra, SQLite, MongoDB, MariaDB, InfluxDB, SQL Azure, Amazon Aurora, RDS and Redshift, Google Firebase, and CSV files. In this presentation, we'll see how to use all of the logging types of open automation software and see how to network data from remote OAS engines, and which implement store and forward both on network failure and database engine access failures. We'll see how to use setup manually, also with a CSV import and programmatic interfaces with .NET or REST interface. One-click automation to set up your data logging from all of your data sources. We'll also see how to reference high-speed data logging from controllers or .NET applications, and how to implement transaction logging to record all of the transactions that each logging group is going to execute. And the first thing that you'll need to do is you'll need to download open automation software either for Windows or Linux. You can also use Docker deployment. You can even run open automation software on your Raspberry Pi device. So everything that you're going to see in this video is related to all of those platforms. The only exclusion to that is Microsoft Access database engine will only work on the Windows OAS engine. So after you install open automation software, you will have set up your data sources under configure tags and drivers. So view our knowledge base at openautomationsoftware.com, and we're going to follow along with the guide within our knowledge base under data destination. So under data sources is where you define what data you're going to log. Under data destinations, we're going to use data logging under the getting started data logging article. You'll follow along with that. We'll also, in this video, we're going to go pretty in depth in all of the properties, but the first part, we're going to get some quick success logging some simulated data. So let's do that. So we'll select configure data logging, and if you haven't logged in yet, you'll do that. Specify your username and password. And then that'll automatically connect you to the local service. If you want to connect to remote OAS engines for setup, you can do that as well, either using the standard networking or the live data cloud feature, both which are free networking features included with OAS engine product. First type we're going to use is the continuous type. We're going to log at the default of a 1-second rate, but you can specify any rate that you want to log at. Then under the tags is where you map what the tags that you want to define to log. And what I'm going to do is I'm going to select some of the demo tags from the system. I'll select ramp.value from the tag browser. The field name can be anything you like. And we're going to specify the data type that's going to be created in the database table. And we'll select OK. And we're going to add a few other types here in this example. If you want to set up the data quickly to multiple tags, you can use the CSV Export and Import right there in the tag window. That's selected right here. And then you'll use Microsoft Excel to edit that file to then import the changes back in. So I'll select ramp, random, and sign to log. And I'll set each of the field names to that. Then I'm going to specify where do I want to log this data. And if we're going to log to a database, we'll go to the Database tab. After you select Log to Database, you can then select which provider that you want to use, which database engine you're going to log to. We're going to use SQL Server in this example. The next thing we need to do is set the server for where the data is going to be recorded. And it doesn't matter for us if it's a local or remote database engine, because we're going to buffer that data on a network failure, so you'll never lose anything on temporary network loss. For SQL Server, I'm just going to connect into my local one. The easiest way to obtain that server name is right here under the SQL Server Management Studio when I select Connect, and then I can copy that server name property right there. Next, I'll set up define what the database I'm going to log to. If the database doesn't exist, it will create it. And with the table, we'll go ahead and type in continuous. Then we'll specify the logging group name that we're going to add. And I'll use continuous for this so we can easily identify it from our list. But you can use any name that you would like. So now when I select add group, that has begun logging data at the 1 second frequency of these particular tags. So let's go into SQL Server and let's expand that database, and we need to refresh our tables because that table would have been created for us. And there it is. If we just query that, there we see the values logged in the format. Now the resolution that we have with the timestamps is down to 100 nanoseconds. And you're seeing the time logged here at the 1 second frequency because that's what we've specified to do. In a moment, we're going to dive into some of the other types like data change, and we'll see the time resolution come out to that. But with the 1 second frequency, we're indexing the values that we've received, and we match it up. Does it belong at this record or the next record, depending upon what time that it needs to be recorded. To save the changes of your configuration, click the Save button on the toolbar, and we'll just put in a new name of my data. And it prompts us to set this as the default configuration to load. You will want to select yes so that it puts under configure options the default configuration file to load. If you want to change that at any time, go to configure options. We're just going to take a look at it right now. Notice that it has set my default data logging configuration to the file that I just saved in that. Now here we've logged the data in a wide table format, but if I want to, I can set up the continuous narrow format, which logs each value on its own record. So let's see how that is done. So if I change the logging type to continuous narrow, I'll change the logging group name here to continuous narrow as well. I'm not going to apply changes. Instead, I'm going to add this group in a moment, but I'm not done yet. I want to then map the tag names. Instead of fields, I'm going to map them to an alias name. So when I select ramp, I have ramp.value as the tag, and the alias can be, I can leave it at the default there, or I can just change it to what I would like it to be, any characters that you want to define. And again, we can use the CSV Export to set up all of the tags. Let me just grab a few others here manually. I'll select random and also sign. There I have that alias name. So under the database tab, we're going to log this to a different table called narrow. Now I've put a space in there. You probably don't want to do that if you're using third-party reporting systems. I just want to show you that OES does support special characters and also spaces included in table names and database names and also field names. So let's add this logging group now to the configuration. If we come back to SQL Server Management Studio, and let's again refresh the table list of tables. We have a new table there, and if we select this one, we can see the format's a bit different. In that we have a column for the date and time, we have a column for the tag name, and a column for the value. Now notice that I have my field names set to tag name and data value. I wouldn't want to use value as a field name because that's a special reserved word for a lot of database engines. But notice each time that, each second, we're going to log the new values for each of those on their own individual records. The next type is we want to look at event-driven. With event-driven logging, what we're doing there is we're going to define a trigger tag that is then going to take a record to be logged. So I'll go back to the continuous type. I'm going to log these tags, but instead of continuously, I'm going to log them based upon an event. And I'll change the logging group name to event. And this is event driven. And we'll browse for either an integer tag that changes to a non-zero value. That will cause a trigger. Or we can browse down to, let's see, I've got this tanks example. And if I take a look at tanks pump dot value, okay, and when with a Boolean, I can log that when it transitions from false to true, true to false, or both. Under the database, instead of the table continuous, I'll log this as the event. And we'll select that, add to that logging group. We'll come back into the database management tool, and we see we have a new table here, but we don't have any data yet in this table. So I have a handy .NET application that is tied to that pump signal. So what I'll do is I'll just click on that pump to turn it on. And now, when I execute the query, I see I have one new record that's being logged into that table. And if I trigger this multiple times, basically for every transition that I have a new record that's being recorded of that time. Event-driven logging is commonly used to do some handshaking between the controller and the OES system. And to give that feedback to the controller that we have successfully logged that data, we can select Enable Confirmation, and then we can browse for a confirmation tag that might be back to an Allen Bradley controller or an OPC UA server, and that's going to give that true indication that the data has been successfully logged and we're ready for the next set of data. So we've got really nice handshaking that occurs back and forth here. If we wanted to confirm that immediately and let OES take the responsibility to log the data to the database, because we do have store and forward that I'll show you a little bit later in the video, you'll see that you can use this property to do extremely high-speed transaction recording from controllers, and then move the data on into the database when it can. So that, if with this property checked, that'll be the fastest performance that you can do. We also have the error tag feedback that can be tied to an integer tag that if there is a problem, it'll be non-zero. It'll write a non-zero value back to the controller that there was an issue logging that particular set of data. Now, so far we've been logging, say, at 1 second or based upon event. If you want to log data faster than what the data can come in at OES, so the OES Allen Bradley drivers that we can see how to define them under the data sources like Allen Bradley, Siemens, and Modbus. Those are the fastest performing drivers you're going to be able to use talking to controllers. But you can also talk to OPC UA servers. And as long as they support the data resolution down to 100 nanoseconds, OES will log it. And we can see a few examples of that. We even have some videos demonstrating if you want to log faster than what your OPC UA server or controller can support. One of the things you can do is you can log buffer data from a PLC or an OPC server. So in this way, what you're doing is you're buffering the data into arrays, and this video will just walk you through how to set up high-speed data logging at the fastest clock interval that the controller can support. Usually that's about 1 millisecond. So typical communications to a controller with the OES drivers is about 15 milliseconds. Some of the OPC servers will go about 50 milliseconds, but if you need to go faster than that, this is the technique to use to do that. We also see how to log high-speed data from a .NET application, so from software applications. This is the way to do that as well. This demonstration is shown using our OES.NET data connector as a data source. Now, how this is possible is that OES with SQL Server, MySQL, Oracle, and all the NoSQL database engines, we're going to log data at a bulk insert. So data can occur going to even a remote database engine, millions of records in one call. So under the database tab, you'll see a property for that called records to enable bulk insert. So if there's more than 10 records to log, revert to a bulk insert. Otherwise, it'll do a single insert with SQL Server, it basically automatically creates a stored procedure, and then it makes that call to that. If you want to log to a stored procedure, that's one of the things that might be of interest to you. Then instead of the table name, you're going to define to log to a stored procedure name. And then under the tags tab, instead of fields, the field names would be the parameter names of the stored procedure that you're going to log to. So with a bulk insert, one of the things that you might run into is that you need to have track a trigger on your database. We don't really like triggers because they do slow down our performance. So we can't log, say, 1 million records per second. But instead, if you do need to define a trigger on your database, and that's usually found under here, then one of the things you'll want to do is you'll want to turn off the high-speed bulk insert. So to do that, just put in, say, 10 million records to define. That's how you would do it, and then it will revert to always call the single insert, so they'll fire that trigger for you. We also have the number of records to pass in the bulk insert. So if you define, say, this to be 100,000, then it will only pass, it'll break up the bulk insert into 100,000 records at a time. If you leave it at 0, then it sends all of them all at once. Let's go back to the next type, which is event-driven narrow logging. Same type as our continuous narrow format. It's just we're going to trigger it based upon a Boolean condition. So I'll do this as well. I'll go back to the continuous narrow type. I've just copied that trigger tag. And with this one, we're going to say event narrow is the logging group name. And we're going to go to the table event narrow. And under the common tab, we'll want to define this to be event-driven narrow. And there I'll just paste in or browse for that pump tag, tanks.pump tag again, and I'll select add group. We should now have a new table under the tables called event-driven narrow under the SQL Server Management Studio. So we query that. We don't have any records yet, but if we trigger this and then execute the query, we now have 3 new records. Basically, it's logged each individual tag on its own row into the database in the narrow format. Now notice the date and time on this. This is the timestamp of that tank's Boolean tag that matches up. So when that is when the trigger actually occurred. So when you're doing event-driven or event-driven narrow logging type, it's going to use that trigger timestamp. You can see that easily. Let me show you a quick technique to do that, to see that timestamp. If we go back to configure tags, and let's take a look at under tanks pump, what I'm going to do is right-click on that and select add to watch. And there I can see that timestamp at 22:15:74. That matches up. Let's bring this side by side here. We now need the watch window. So if I bring that over somewhat close to the, you can see the full resolution is down to 100 nanoseconds on everything that's recorded from OAS. So if you want to override that, I want to show you a particular topic under configure options. If you're logging data from an OPC server, the data will be logged using the timestamp from the OPC servers. That's either the classic DA or OPC UA servers. Now, so if you don't want to use the timestamp from the OPC servers, but the local CPU clock of when the data arrives, you can uncheck this option. So sometimes the OPC server will be on a different system, on a different time zone. I have other techniques as well to record that, but that's where you can override that to log just the local time. Also under the time tab, you can log data. All of the data in the OAS engine can be set to use UTC time, And that does it right at the data source as the data is received. It still uses the timestamp from the controller or OPC server itself. It just converts it to UTC time. So you can do that option, or under the data logging group, you can just do it per logging group. Under the Common tab, we have a property called Convert Timestamps to UTC. So that convert the timestamps just for that one logging group. If the data is coming in as UTC, you optionally can convert it back to local time before it's logged as well. Let's look at our next type of recording type, which is snapshot recording. Snapshot recording is a way you can go back in time to record all of the values prior to a particular event. So I'm going to put in a new logging group name called Snapshot, and I'll specify the logging type to be Snapshot, and under the database we'll just go to a new snapshot. I've added this snapshot recording group to our logging configuration, and what I'm doing here is I am keeping track of 60 seconds prior to the event. So right now, if we go back into the SQL Server Management Studio and we refresh our tables, we have a new table called Snapshot, but we'll see that we don't have any data within that. Now I've waited 60 seconds and now or more, and now what I can do is I can trigger this Boolean condition. Okay, so that when this pump goes to true, now we go back in time to grab all the values for 60 seconds prior to that event, and we record all of that. So that's what snapshot recording does. Our next type is at a specific time of day. That one's pretty simple. We just want to record the values at a particular time of day. So with that, we just set the logging type to specific time of day. Then you define right here at what time of day the record should be taken. Notice that we have the property to say set date to previous time. So one thing you might want to do is say log at 10 minutes after midnight. This is very useful in like water treatment facilities where the RTUs capture all of the data for the prior day, and now that data, those data totals are associated with the previous day. So you can use this property right here to set date to previous day if you want to set it back to that particular time. We don't want to wait for 24 hours for a specific time of day, but you get the idea that instead of it being trigger based on an event, it does it just based upon time. Our next logging type is based upon data change. So what I'll do is I'll come up to the continuous type, and with the continuous type I'll say this is based upon data change row. So there'll be one row for all of the fields that we're going to log that's defined under the tags tab, and we set this as data change row, and under the database tab we define this table name as data change row, and we'll add this to the configuration. Now what happens, anytime the values change, it logs a new record. So let's refresh this, and we have data change row, and we want to query this. So there we see basically exactly the same as the continuous logging, because we have simulated data that's changing once per second. But let's actually add one more tag to this logging type so we can see it. This tag, well, we could even change, say, the data rate of the simulation or something like that. But I know that ramp2 has a different update rate at 100 milliseconds. So let's add that to the configuration. Here we'll see an example of updating an existing logging group. And this, you'll see how you can add fields after the logging group is created to this type. So this is a data change row. So instead of these specific fields, I'll just change the query to select star from that table. And we see we have a new field called ramp2, and we have null values Then we have null values to a specific point, and then after we get to the point where the values are being logged for ramp 2, we see that ramp 2 is changed, whereas the other values are staying constant. So there we're seeing the actual effect of the data change row, that a new row is triggered by any change in any one of the tags. Now we can also do data change narrow. So the data change narrow type is going to log an individual record for each value change that occurs. Let's use our continuous narrow type as the base model, because we already have the tag aliases set up for this one. And if we just come into data change narrow, and I'll change the logging group name, as well as the table we're going to log to. And we'll add that to the configuration. So there we had the 3 tags that we're logging. So anytime they change, it'll log a new record. So we'll come back here to the tables, refresh this, and we see that we have a new table called data change narrow, and let's query that. And so every time that the value changes, we get a new record written into the database. And so notice it records the date and time, tag name, and value for each of those rows. So we've seen how OAS can log data from its own local OAS engine, but what if it was a remote database engine? So to demonstrate this, first I want to refer to an article under our knowledge base under typical deployments. So networking is included in OAS, and to give us the best data resolution possible, because in a moment I'll show you that we can do store and forward functionality. So what we want to do is we want to be as close as possible to the data source. So currently, in all of the examples we've done so far, it's been on the on-premise configuration where we have one OAS engine talking to a controller, logging to a database. But if we wanted to do basic networking or live data cloud, we can then take a look at this model, which is we have multiple OAS engines. We have one or more OAS engines that would be communicating to controllers or the data sources, collecting the information, and then it would be networked to a data logging system. And you can actually have multiple data logging systems. So one-to-one, one-to-many, or many-to-many configuration. It is completely up to you as to how many data logging engines and data source engines that you can define. So a data source engine can support multiple data logging engines. A data logging engine can support multiple data source systems. To see that network syntax, it's very easy under our knowledge base, under the networking guide. We're going to start with basic networking, and that's if the data source has a fixed IP address. So this would be the tag name that you would define as a syntax to connect to that remote tag from that remote OAS engine. So if I just come back to the data logging configuration, so we'll select one of our existing logging group types, say data change narrow or wide format, and here we have a couple tags already defined. If you're doing multiple data source engines from different time zones in a data logging group, event-driven or data change is totally fine to do that. With a continuous type, you are going to want to have all of the time zones within the same time, or use UTC time. That was the best way to do it, is to get all of them indexed properly onto the same time, so you can compare the multiple different data sources from different time zones into the same data set. So what we would do here, instead of connecting to a local OAS engine, we'd connect to a remote OAS engine. I'm just going to use, you can follow along with this as well. You should be able to use this IP address, 127.0.0.1. that represents actually your local system, but it will give us the network syntax of that. So let's select ramp 4, something like that. So there we see the full network syntax. We're using basic networking for a remote OAS engine. So if we have a network loss between the OAS engines communicating to each other, the data will be buffered at the data source where it resides, and it'll be held until the network can be reestablished. If we're using live data cloud syntax, that's where the data source engine has a dynamic IP address, and we would bounce off what is called a remote SCADA host node. And that is a live data cloud hosting node. In this example, I'm going to use just my own local network node as the hosting engine as well. But I have a PC subscribed to the remote engine as well. So when I hit select, and I select that ramp signal or ramp 2, there we see the full network syntax. We have the remote hosting node, and then we have the key name remote SCADA hosting dot, and then the live data cloud node name dot, and then the tag name and variable that we're going to log. That also brings up another point. There are over 700 parameters, and it's constantly growing as to the number of parameters that a tag supports. So you could log anything of a tag, like alarm limit values, maybe the description. That can all be logged directly from the tag. So the tag support value is the most commonly used one, but you can support even log time on and count values that are set up. So to see the full network syntax and some examples of that, visit the article under the knowledge base called networking and look at either basic networking or live data cloud networking. And there is also a getting started networking that discusses all 4 networking features. Now, what if your network fails to your remote database engine or say to your OAS data source? So to set up the store and forward, it's already enabled, by the way. If you go to configure options, the default store and forward directory that the data is going to be stored to is going to be in the store and forward subdirectory of your OAS installation directory. I have changed mine to a directory called buffer. So currently on my local system, I see that my buffer directory is empty. So I currently have no issues with the logging of these logging types. But let's replicate database failure. So what I'll do is I'll go to my database engine and I will stop it. And a prompt will appear in SQL Server Management Studio that says I want to stop this. So with store and forward, we're now going to be buffering the data. So you can see the time. What I'll do is I'll right click on the ramp tag and I'll select add to watch. And we'll watch this signal. And the ramp signal, the timestamp is currently at 10:48 and 07 seconds. So the data has been down now the database has been down now for a few seconds. And so at this particular time, we are now buffering the data into some files. So if we go look in that directory, that buffer directory, we now see that for the logging groups that are executing, we have some buffer files. They have the extension .dlb. We also have some system errors. This red flashing indication, if we click on that, that will take us to the system errors, and we see that we have some problems with these logging types. We can't open these database connection. We can't write this data to these logging types. We're not seeing some of the other types because they're event-driven because they haven't been triggered to log. But if we just say cause a event-driven execution, we'll see that they are now also in error. So all of the logging groups are in error at this particular time. So now what we'll do is we'll resolve that problem. We'll start the database engine back up. So the database engine could be down for, say, several months. And this data will be accurately and reliably be buffered into that directory. The reason that we buffer it into files is that, one, we're not going to use up RAM of the system. Might be running on a Raspberry Pi device, and you're going to run out of RAM pretty quickly doing that. So you might have an external disk where you have that as your buffer directory. Or you could be going across a network, and the data source engine itself will buffer the data that's feeding the remote data logging engine. So that's another way to do it. It's common in like marine applications or transportation, where you have a locomotive that it's away from the station on a journey, and then it docks into the station. It offloads the data each time it comes in, or maybe if it's a ship that docks in its port. That data is then, that's been buffered over the time period that's been away, then moves the data on into the data destination of the database. So let's start the database back up. So we'll start this. And now if we go look in the buffer directory, we'll see that these files will disappear when the database connection is reestablished. There we see the files. They disappear pretty quickly, but keep in mind they are being processed one at a time to not overwhelm your network. But to the human eye, it's pretty fast because we only had probably 10 buffer files there. Now, we can't come back to directly make this query again. We have to close all of these down because that's just something SQL Server Management Studio does. But let's come back in here now to the continuous type, and we'll select this again. And we are limited out on the 1,000 rows. If you've been logging longer. So we can also change this query to say order by date and time. And so let's execute that. And now if we could jump down to that time, it was at 10:48 at that particular time that the database engine was stopped. We have data that's been retained, and that's true for all of the logging types. So there is the data. That's an example of the stored forward functionality, that you won't be losing your data on a database engine failure or a network failure. Let's go back into the data logging configuration and take a look at some of the other properties that are advantageous. Under the Common tab, we have this property called Do Not Buffer Data on Air. Now, that property overrides the stored forward functionality, and it will reject and throw away those records if there's a failure due to a network loss or database engine failure. So that way you don't have to use the store and forward functionality on a specific logging group if you don't want to. Under the database tab, you'll see some properties there to discard null rejects. So if you've modified your table, and I'll just jump back into SQL Server so you can see how this is done. So sometimes our customers will not want to have bad data quality being logged into the database. So let's say your data source from that OPC server fails, and then what would normally happen is you'd see null values being recorded into the database column, the field itself for that particular tag that is bad quality. So sometimes our customers will design a column, and so what we'll do is right click on this to say design, and by default the only field that doesn't allow nulls is the date and time that's being logged. The rest do allow null values, but sometimes people will turn this off in each of the columns, and when we do this, then when you have bad data quality, then the data will be buffered because it is not able to log the data. So instead, you can move the data along to the next record with the property discard null rejects. So that's what that property is used for. Also, if you have a continuous logging, it automatically sets a primary index up on the date and time. But if you're logging, if maybe you create your own primary index and it's being violated, you can choose to either update the existing record or you can throw that record away. So if you select this option, the record will not be updated. Instead, it will just reject the new insert entirely because it violates the primary index. That's what that property is used for. We have another property called update records with a query string. When that's enabled, you can define either a static query string or a dynamic query string from a tag. We have another section in our knowledge base that goes into detail of that in a video. So if you go down to the video section of data logging, you'll find the video called Update Records. And that's a demonstration. It shows how it's updating records based upon a dynamic query from another tag itself. Notice that you can also set the server name, database name, and table name based upon other tags as well. So you can have data coming from a controller determine which database or table that you want to log that data to. That's what those properties are used for. These would be string tags, by the way. You can also delete data. With this property enabled, you can define how long you want to retain the data in the database. By default, it's going to retain it forever, but you may want to automatically clean it up after, say, the default is 90 days, but maybe after a couple years you want to roll that data off. It's been archived, and you can use OAS to do the automatic clearing out of the old data if you want to. Let's do an example of logging to a CSV file as well. So we'll use the continuous logging group already that's defined. And what I'll do is I'll just browse for a local drive. I'll just log it to C data. And then I'll just put in a new file name here called continuous. And notice I can also change that file name based upon a tag if I want to. The default extension is .csv because that's what it will be. But you can make it to where it's not comma separated variable data. You could change to any separator character that you would like it to be. But the default is going to be a comma. By default, automatically appends on the day, the year, month, and day onto the file name. But if you want to just make one file per year, you can use this option, or maybe one per month, one per day, which is basically the default, or one per hour, one per minute. That's up to you. And you can set it to override the file. I'm going to use the default to just append the date to that. You can optionally include to disable the header. I don't know why you'd want to do that, but some actually do. Just want the raw data without knowing what fields they're mapped to. And you can also overwrite the file each time, so it only logs, say, just the latest set of data and starts over fresh each time that a new record is to be taken. So let's click Apply Changes to this continuous logging group. And what we'll do now is we'll go back to this directory called C data on my system. And now I have a new file called continuous. Now, one thing about Excel, when you open a file with Excel, it will lock it. So at this point, we're now in data buffering mode. We see the date and time here. In order to see the full date and time, we need to format these cells. That's one thing that Excel likes to do, is just recommend a default date and time. But you will see that you do have the full date and time resolution in here. Down to 100 nanoseconds is recorded in that. So at this particular time, the data is now being buffered. So if I go back to this buffer directory, let me open that up. I should see a data buffer file located in that one. And it is for that CSV logging group of the continuous. So if I close Excel, And the last record, notice the last record in was 11:44 a.m. So I close that. The data buffer file disappears. It just does it that quickly. And now I open Excel again. And again, we'll format the date and time. So 44 was the last record, and then we have the additional records while Excel had the file open as it was being buffered within that. If you want to have just live data coming into Excel, you need to use a different product that we have called the OAS Excel connector. And that allows you to put in a formula to have live tag values from either remote or local OAS engines into that. So this is more for data logging to appending onto a CSV file, which are basically just text files, but very efficient. Now, so far we've been using OAS to manually set up the data logging groups, but we can do other ways. There are other ways that you can use to set up data logging, and that would be programmatically with a .NET or REST interface. To see some documentation on that, jump back to our Getting Started guide. And in our knowledge base, you look under the Programmatic Interface. We have the .NET Server configuration, and here is a section on how to set up data logging groups. And this is free for you to use, both with either the REST API or the .NET interface. So there is no product feature required to use the Programmatic Interface for configurations. For live data, you do need either the .NET Data Connector or the REST interface for live REST data. But for configuration, we've opened it up free for you to use. And then also for the REST API, you look under Programmatic Interface, and here is the section for the REST API. And you can use Postman, prototype your REST calls with Postman to read or set configurations. Another way to do configuration is with a CSV export and import. So the reason I say export is first we want to export this to the logging groups. And so what I'll do here is I'll just use a file name called base. I'm going to export all of the logging groups so you can see what that looks like. So if we go into that directory where we've saved this CSV export, we have one file called base. And if we open up that has a record for each of the logging groups, but then it has a corresponding file for the tag. So if we look at the narrow type, you see you just have two fields, one for the tag name and one for the alias name. For the wide format, you have a few more fields, one for the tag name, one for the field name, and then of course the data type. And if they're string tags that are not NV char, you have like the number of characters for that string. And there we have the insert only. Remember I mentioned that update feature? If you watch that video, you'll see what this particular property of the field is important for. So you can make modifications to any or all of these CSV files with Excel, then perform a CSV import, and it'll automatically update that. Another way to set up data logging is with one-click automation, and it's called the one-click data logging feature. So one-click data logging is going to automate the setup of your data logging groups to grab all of the tags defined for a logging type. So to do this, what we'll do is we'll select one-click data logging. And first we can optionally browse for a local or remote OAS engine tag group. So if I select this, and let's say I just use the local host, then I can choose a group as a starting point. Or I can leave it blank, which I'm going to do in this example, to log everything from that OAS engine. And then I can put in a new base group name. This is going to be the logging group name. I'll call it one-click data as the logging group name. And then if we go to step 2, we determine what type of logging that we want to do. We've already discussed all of these. And if we're going to do a wide format, we're optionally given the ability to change how many fields we want to maximize each logging group to. So if there's more than 500 tags that we're defining, it'll create multiple logging groups. Based upon your database engine, you're going to want to use that. If you're using the old legacy Microsoft Access, it's limited to 255 fields. So you want to crank this down to less than 500. But if you're using any of the other modern database, like especially the NoSQL stuff, you can go way out on the number of fields in a wide format. Continuous narrow, or any of the narrow types for that matter, it's not applicable because all the tags can fit under one. In step 3, we really don't define any tags. Step 4, we're going to log to a database engine. I'm going to grab that database engine here again using the SQL Server Management Studio. So you can see where that comes from. I'll use the same database called DataDB. And the table, it automatically defined that as one-click data, but you can override that if you want to make it whatever you prefer. You can also go to CSV files in step 5. So when you click OK, it automatically adds that logging group. Here it is, one-click data. And it's automatically defined all of these tags. It's determined what field type they need to be based upon their data set. Be string, double, boolean, various things. And it's logging it to this data here, this table. So if I refresh my table, and there I have a new table called one-click data, and if I select that, I can see I have a lot of fields defined here. And there is all of the data being recorded for each of the tag values being recorded. So you can see very fast. It only takes just, I don't know, about 30 seconds, and you can be logging all the data. But then you can optionally come in here to either delete or use CSV Import Export to control maybe a subset of that automated import of all the tags. It's up to you. Now, as you go forward, you again want to save your changes so that if you do a system restart, that data is automatically saved. If you want to see some details of what each data logging group is transacting, we can jump into Configure Options, and under System Logging, we have a really nice feature that is called Log Data Logging Transactions. And it looks like I had this enabled by default already, but you check this box, and then further down, you go specify where you want this data to be to reside. Now, because I had it already active previously, I already have some data within this directory. Let's just go take a look at what that is. So each time that the logging group transacts, like the continuous ones and the data change, they're automatically putting data into these files. And notice that the file name has within it the logging group name. So there I have continuous narrow, continuous, data change, and so forth. So I've got some for every single one of these logging types, including just my most recent, the one-click data one. Let's just look at continuous narrow. That'll probably be one that just has a few tags to look at. And so in this, we see some transaction logging of the raw values coming into the logging group. And then we're going to see one record of a single write. Here it is right here. The data to be recorded right here are the values that are being recorded into that database. So it's very useful to see not only what the data source is, but what is going to the database. And if there's an error, it'll show you what that particular error exception is coming back from the database engine right in that transaction log. So it's a fantastic way to do some troubleshooting on your data. The other ways to do some troubleshooting is under system errors. often you'll see that I had this red flashing indication when I had data buffering occurring. So here we had data buffering. It was in a data buffering state, but now it's no longer in a data buffering state. And each of these logging groups I had caused in a failure state because I had the database engine was stopped. In fact, we can do that again. If you stop the database engine, any system error that is red, it becomes then an active condition. So we'll see this indicator start to flash red. And then when you click on it, it'll take you to the system errors, and you can see what particular logging groups are in failure. Notice that the event and the snapshot are not in error at the moment because they don't have that trigger from that Boolean. But the other ones that are being active, there is a problem with those. So right now, the one-click data, it has a problem writing this data, and there is all of the data that is to be recorded into the database. So we'll start the database engine back up, and we'll resolve these system errors. If you need some guidance on your data logging setup or possibly your data source, you are welcome to reach out to us at support@oasiot.com. That's the best way to start a support ticket. You can also visit our website at openautomationsoftware.com, and there you can review our knowledge base that we've been going through and all of our products. And there we can see we have the .NET SDKs and REST interfaces and web interfaces, visualization tools, IoT connectors to Azure, AWS, and other cloud systems, device and data connectors to the different drivers. We also have alarm logging. A lot of what is shown in this video is also applicable to alarm logging when it comes to store and forward. But the alarm logging, you're just going to define filters. We have another video dedicated to that topic, as well as the recipe connector. That's also something that may be of interest to you. And how to get data from a database is you would use what is called our recipe feature. And you can do this based upon continuous or based upon event to extract data based upon a dynamic query. And there's a video describing that listed right here under the video recipes. So we look forward to hearing from you, from your success. And if you like what you've seen in this video, hit the like button. And I appreciate the time to review the OAS Data Historian.